Okay, so school has changed a lot since I was at school. When I was at school, I didn't do any statistics from year 7 to 10 at all. But now it seems that you do it every year, apart from last year. Is that right? So did you see box plots, dot plots, stem plots, bar charts? Yeah. So I'm imagining that there may be very little that's new in this chapter. It's just a question of whether you learned it in previous years. All right, so let's start from the beginning. Um, I'm going to draw a diagram. So right now, I'm saying we're statisticians, and our job is to understand data. That could be data that I collect by doing a survey. You may have done surveys in year 7, 8, and 9. And there are different kinds of data. So I'm imagining you drew a diagram like this in previous years, and you might have used two words, categorical and numerical, to distinguish between the different types of data. Um, why do we want to do this? Because as you'll see later in this chapter, depending on the type of data we have, we're going to use a different picture. And we're going to use different statistics. So the reason why we're making classifications is because it's going to guide the decisions that we make when trying to understand the data. So we need a definition. It's one thing to have words, but we need to understand what these words mean. So um, would anyone like to offer an explanation for the difference between categorical and numerical data? Maddie?
Doesn't numerical have to do with like numbers and amounts, and then categorical um is like things?
Okay.
But I don't actually know. But I remember doing this.
Yeah. So you don't write this down. I mean, you can. It's fine. I like this. I like things.
Like objects and stuff like that.
Yeah. So
And numbers is like prices and
yeah. Okay. Yeah, I like it. So one possible issue with this is that we've kind of used the word numbers twice here. Um, I think it's easier to classify than it is to make a definition for these. So, but I'm happy to go with this. So numbers. Let's go with numbers. And I'm going to add one more statement. This is where I think you probably didn't do this last year or the year before. It makes sense to calculate the average. And by average, in this context, I mean a statistic called the mean, which you obtain by adding up all the numbers together and dividing by the number of items in the list. So, for example, the average, and I really mean the mean, pardon the pun, of 50, 52, and 54 is 50 plus 52 plus 54 divided by 3, which is 52. So I'm trusting that you've seen a calculation like this before when you've calculated the average. Is that right? You've seen this before? Okay, if you haven't, then I'll be scared. I'm scared. All right. So the reason why I've included this second sentence is because some things have numbers, but they're not actually numerical. Maybe I'll do a couple of examples of them. All right. Categorical. I like things. I like objects. or let's just say not numerical. Okay? Whenever you can add, subtract, and take averages, you've got numerical data. If you can't do that, then you're dealing with categorical data. Okay? All right. Let's practice. I'm going to give you some items. Not. Yeah, not numerical. I'm going to give you some items, and I want you to tell me whether you think they are categorical or numerical. So the first one is going to be height. So who was that?
Numerical.
So Maddie, you think it's numerical? Why is that?
Because it's a number.
Yeah. Okay, that's a pretty obvious one. Okay. What's the postcode of Alexandria? Is it 3714? Okay. So I'm not originally from here, so I actually forget most of the time. Um, well, obviously I moved here to teach.
No, I know, but like, do you live in this town?
Yes, I live in the town.
Don't you live in this town?
Huh?
Don't you live in this town?
No, she moved out last year. She's got her own house now.
Who else lives in?
It's just me now. Don't come to my house.
I know where you live. I will. I know where you live.
Yeah. Don't do it. Don't don't expect me to entertain you at the door with food or anything.
I don't.
I'll just tell you to go away with a smile on my face. But yeah,
You're gonna leave.
yeah, you can leave now. Yeah, yeah. Don't come to my house.
Has a student ever come to your
Nope.
house before?
No, no one came during trick or treat. I was very relieved about that.
Yeah.
I didn't want my year 8.
Everyone, we've got to go to Mr. Chu's house for trick or treating now.
No, I didn't want anyone from my year 8 class to know where I lived. Anyway, so we're digressing. We can come back to the digression later if you like. Postcode. There's a number. Do you think it's numerical?
No, I want to be categorical.
Why do you think that, Jess?
Postcode. It's like kind of like a thing. It's I bet you it's I bet you it's categorical because it categorizes each. No, you're not trying to add them all together.
All right, Maddie, you were saying something really interesting. You think it's categorical because it categorizes?
Each town and like it's numbers, but say you change it easily to like letters and have it as a combination of letters. It's like a number plate.
Yeah, it's just a code.
Exactly, it's a code.
Yeah.
So I think that it's categorical because it categorizes each area of it.
Yeah,
So
great.
not adding them together.
Yeah, it doesn't make sense to find the average postcode in this room, does it?
We could.
I mean, you could, but it would be junk, right? Yeah. So I want to draw this to your attention because this has come up a few times in year 12 exams. They ask people to categorize variables, and they put postcode up one year, and a lot of people thought it was a numerical variable because it was a number.
Are you saying I'm right?
I am saying
And I
you're
was
right.
wrong when they told me I was wrong?
So the most important sentence when categorizing numerical data is not the fact that there's numbers, but that you can calculate averages and totals. Okay? All right, we can do one more. So what are the 4 houses? Weinberg, Cumming, Bainbridge, and Long? Is that right? So it's categorical. There's no numbers here, so it's pretty obvious. So we don't even have to decide whether it's numerical or not here. Okay? All right. You guys all right with this? Okay, let's move on. So we're going to add 2 more branches to this tree. And maybe I will do it on the next page. So what I'll do is I'll copy this. With the power of technology, I can copy and paste my handwriting. Okay. There are 4 more terms you need to know. And I think you've met them before. So does anyone want to try naming one? Emily? Oh, not a hand? Maddie? Okay, so those are summary statistics. Here we're just talking about classifying variables. So that's coming soon. Okay, there are 2 types of categorical data, 2 types of numerical data. We need to know these.
Discrete, continuous, ordinal.
Great. So was that from the book? Okay. I mean, you had the book open, so.
No, not at all.
Okay. So I actually think telling the difference between these is easier.
What's the first one?
Nominal. I'll write it more clearly for you. Okay. So here's the idea, all right? If your data is ordinal, that means the categories can be ordered. So O for ordinal. That's how I remember it. Ordinal data has a natural ordering to the categories. However, nominal data, no natural ordering. So if you can't order the categories, your categorical data is nominal. So let's see if we can decide in the following examples. Let's say I give you a survey. And let's say I ask this question on the survey. I'm actually going to give this survey to you very soon. I'm going to ask the question, Mr. Chu's explanations are clear. And you're going to select an option. You might select from strongly agree, slightly agree, slightly disagree, strongly disagree. So the variable that I'm interested in is your choice of response to this question. What do you think? Do you think there's an ordering to that?
Is this the categorical, like the?
I've already given you the hint that it's categorical because I haven't talked about numerical yet. What I want to know is whether this is nominal or ordinal. Okay, so a lot of you are saying ordinal. Why?
In order from most degree to least agree.
Yeah, so you can order it from agree to disagree or from disagree to agree. So there is an order to these categories. So for that reason, there is an order. And so for that reason, this is ordinal. All right, let's do a different one. Got to come up with an example. So let's go with.
What if they were like colors? Does that mean nominal?
All right, that's a great question. Colors. What context are we using colors here?
I don't know.
What are we using?
Like say if you have like pink, purple, blue, that I know it's nothing to do with numbers, but
Uh-huh. Let's say the colors on your clothes. Let's say I go out to 50 people tomorrow in a town center and I write down what color they're wearing. Okay? And some people will be wearing white.
yes.
Yes. All right. So I go out tomorrow, interview the town, and I write down the color that they're wearing. What do we think? Is this going to be nominal? Is this going to be ordinal? Is there an ordering to the colors?
Unless you do it like in rainbow.
Yeah, but what if your color isn't on the rainbow, like white or black? Yeah. So, no natural ordering. But if the rainbow was the only source of our colors, then maybe you could argue that. So yeah, nominal. And we'll do one more. Favorite food. So let's say I interview all of you and I ask you what your favorite food is. Huh? Huh? Yeah, I mean, I could. But what I'm asking is, am I collecting nominal data or ordinal data? There's no natural ordering between noodles and pasta and pizza.
In those two, the first reason, they're ordered into the same category of kind of stuff.
Okay, so favorite food, yeah, nominal. You can't really order the responses because there's so many possible ones. Okay, and one last time. All right, now we just want to worry about the last two labels, which is discrete and continuous. So I think the scientists in the room will know best, but Maddie, you've got your hand up. So why don't you tell us?
My
You are now.
is continuous obviously means continuing. So it doesn't end. Like it can go on and on and on and on. There's a whole song about it, but we won't get into that.
You should sing it for us.
Sing it. You do it then. We don't know what song it is.
I don't know what song it is.
And then which leads me to believe discrete is when it has an end that like can't be broken. Like as in once you get to an end, there's no going further. There's no breaking it.
You know, that's really good, Maddie. I really like that description. It can go on and on and on and on and on. That is really accurate. Okay, so the way that I'm going to try to explain this to you is discrete means only very specific values are possible, and usually you can count them. So if I ask you a question such as how many, often the answer to that question is going to be a whole number. So if I ask you how many chairs are in this room, and you're not being smart and counting a broken chair as half a chair, then your answer is going to be a whole number. How many people are in this room? How many blinds are in this room? How many computers are in this room? Whenever you've got a how many question, usually your answer is going to be discrete.
Does that say countable?
Countable, yes. So I'll write that more clearly for you. All right. Yeah, let's do a few examples now. Time taken to swim 50-meter freestyle. We just had the swimming sports not too long ago. All right, so this is an athletics event, swimming event. Someone's got a stopwatch. They time you. You get a time in milliseconds probably. Is this data discrete or continuous? Don't write it down. It's continuous. Now, let me explain why. When you use the stopwatch, it can only give you a time that's accurate to the nearest millisecond, right? So, for example, maybe you swam it in 0.41 seconds. So let's say 30.41 seconds. But you could have swum it in 30.405 or 30.4049. I'll write this down.
The record is 20 seconds.
All right, I'm going to use a different one, okay? Let's say that's what the stopwatch gives you, right? But you could have swum it in that time, or that time, or that time. All of these times you can't measure because your instrument isn't accurate enough. But what I'm trying to say is your actual value just keeps on going. You don't know what it is. You've just rounded it when you use the stopwatch. It is continuous. Those of you who are doing physics, all your measurement variables are continuous. So just note, the stopwatch rounds the true value. There's also error as well, measurement error, but I won't deal with that right now. Okay, let's do another one. Temperature of the oven.
Continuous. Straight. No.
If you just yell out a random answer, you have a 50% chance of getting it right.
Actually, I have 25%.
Can I hear myself now, please?
Yes.
It's numerical.
Yeah, but that's not specific enough.
Wait, pie chart?
Pie charts are categorical data.
Wait, temperature of an oven. Well, it's kind of the same as the number because you can go. So, I'm going to say it's continuous.
So guys, we're going to finish soon because I'm sensing that I'm starting to lose you. Let's say you set your oven for 160 degrees. You're cooking a pie or something, I don't know. Right?
Some spring rolls.
All right, fine, 180 then. Okay, all right. Calm down. All right. In reality, your oven could be 179.6 degrees Celsius or 179.67. Can you see that a whole range of temperatures are possible? It's just that you can't actually tell what it is.
Because my oven doesn't have point.
Exactly, right? So, for that reason, this is also continuous. So year 11s, shh. I want you to write this down underneath it. Usually when you measure something, it's a continuous variable. Okay? If you have to measure it using a ruler or a digital instrument, usually you're dealing with a continuous variable. All right? You use a thermometer to measure the temperature. You use a stopwatch to measure time. Measured.
I love my second.
Mm?
I heard that you were leaving after the placement.
What?
I heard that you were leaving after the placement. Or something. Someone told me something.
Who told you that?
I think it was my sister. Yeah, something.
Your sister?
Yeah.
What does she know?
After you came here for your placement, for while you were here.
So that's right. I came here to do my placement as a teacher,
Yeah.
and the placement finishes this year.
Yeah.
But I haven't made any decision about whether I'm staying or going. I just want to finish the placement first. I am strongly considering it. All right. Where was I? We're looking for a discrete example. So why don't I just say discrete examples? And why don't you give me some things that you can count with whole numbers? Let's see if we could come up with 3 really good examples together. What was that, Maddie?
Strands of hair.
Strands of hair. So how many hairs on your head? Okay. That's a whole number. How many hairs on your head?
That would be discrete.
You don't really have half a hair, right?
Yeah.
If it's short, thank you. But it's still one hair, right? That you've split.
Half a hair then, because one half of it falls out of your head. So then you've got half of it.
So should we get rid of this example then?
Yes.
All right. You're the boss. We need three good examples. Tyler, what do you reckon? Well, you can after you give me a good example of discrete.
Can I answer a question when I'm back?
Okay. Yes.
Would it be people? Like, how many people? Like, you can't really have half of them.
What is half a person?
But you're still a person.
So I got into this. So guys, listen. So Jackson, Ben, I got into this long debate with my year 8 class last year about whether you can have half a person or 0.8 of a person.
Well, no, but you can't have half of a person because when you put down a group of people
I'm gonna brutally stab myself to death.
they count pregnant women as 1.5 people. That is not.
So when you're when you conceive, is that already half a person?
Yeah, if you're pregnant, then the government looks at you as one and a half,
But where's the other half?
It's just two people. For yourself,
I-
the baby has two things. Yeah, but the baby has a baby doesn't have.
The baby's alive.
So when the baby is born, it suddenly becomes a full person. Is that what you're saying?
Yeah, basically they're saying that if you have it over, then you're half a person. In your body for 9 months, it considers it only half a person. But it's not half a person. It's just one. Can we just
keep it as it is.
I'm gonna keep this one. But this is the problem of using this example. My year 8 class really protested against this one. I mean, a few smart Alex proposed against this one. They were just trying to one up me. If you only consider people as wholes, then you can consider this as a good example. All right. So if there's one person and one fetus, which is also a person, you have two people, and there are no issues with that. But thank you, Tara, for the insightful example. Tyler, you are back. So we need an example from you. Something that we can count. Yeah, like a how many question.
33%
Great. Tell me one. Yeah, well, Tyler needs to answer this question.
No, but you can have half or not.
If you have a little stump, what do you call that?
Tyler, we'll come back to you. Bruce?
How many holes
How many what are in the hoop?
How many holes?
Like basketball group shoes.
Yeah.
Oh, okay.
How many goals? No.
I'm just gonna say basketball shots. Okay, does that make sense?
How many basketball shoes? No, but wouldn't that be continuous if it can continue on? That's indefinite.
But can you have 2.5 successful basketball shots?
Cool, you can play across even like stop.
I think if it bounces out, it's a 0.
All I can do is go to
So guys, this is not going as well as I would have hoped, but you see the how many part here? If someone asks you how many, that's a good hint that you are looking at a discrete variable. Okay. How many people live in your house? I mean, people is a tenuous issue as we previously encountered, but
Actually,
for the most part,
I actually have 6.6.5. What the dogs count? The dogs actually 0.5. My dog identifies as a person.
okay, listen up. I want to collect some data from you now. I hope you're comfortable sharing your favorite sport. I'm not asking for intimate details of your personal life here. Then just pick one, all right? So we're gonna do this for the whole. So shh, we're gonna do this for the whole class, and then we're gonna make a frequency table and a bar chart together. So let's go this way. So Tara, just pick one if you don't have a favorite. Just okay, Tyler. One person at a time. Tyler. Emily. Maddie. Tully. Football. So AFL. Yep. Beck. Jess. Kalisha. Just yeah, dance. Let's go with that. Mac. Favorite sport. Pick a favorite sport. Bruce. Lexi. Okay. Yep. Maddie. I'll just say we. Ash. Okay. Tyler. Ben. And Jackson. Yeah.
Who watches handball and
Is that actually a real thing? Yeah.
4, 6, 8, 10, 12, 14, 16. Okay, so we've got 16 responses here. So, alright, so year 11s. This is, a lot of the time, you won't get to work with raw data like this because there isn't a lot of time in this course. But normally what you want to do is you get the raw data. So I used to work as a statistician, by the way, before I became a teacher. So this was my job, doing statistics. This chapter. Okay, so we've got the raw data. Now we want to tell a story. Now we want a picture. We want to do something with it. Okay, so right now I can kind of see that some sports are more popular, but like Wii seems to be quite popular. Netball seems to be quite popular. Not as popular as the others in this class, unfortunately. Sorry to disappoint. Now, if I have 500 responses, it will be very hard to look at it, wouldn't it, right? So, wouldn't it be nice? Wouldn't it be nice if we had a picture or a table that summarized the raw data for us? That's what we're going to do now. So, the first thing you want to have is a frequency table. All right. So, have you done frequency tables before? Do you know what a frequency is? Okay, what's a frequency? How many? The counts. Very nice. Okay? Oh, by the way, categorical or numerical data? Categorical. So today we are just dealing with categorical data. Next lesson we'll look at numerical data. Time to get a watch. Um, thank you. As you can see, it's actually quite difficult to do this by hand. Down ball. Thank you.
Volleyball.
Yep.
Volleyball.
Yeah, and then we.
And then
Okay. So, how many categories do we have? 11. 11 categories. Okay, so in a frequency table, you're going to have one row for each category. So I'll give these columns a title, a heading. So let's say sport, frequency, and percentage. All right. So now I want to change the data into a form where I know how many people chose each sport.
You tally it.
Okay. So please elaborate. How should we tally this table?
Like next to it, so you can tell only one person did it. So you do one line for baseball, one person,
Yep.
one line. Basketball, one. Cricket, two. So you do two lines.
Yep.
Or right
Yep.
over two.
That's fine.
Either way works. Dance, one. Netball was like three. I can't read that word.
Sumo was 5.
What
are you doing? The 5.
And etc.
Sumo is
7.
Okay.
I thought it was 4. Oh, no.
So um, which one do you find easier to look at? Do you find it easier to look at this raw data or this sort of summary with the counts? If I had hundreds of people taking this survey, this would be much easier to look at. Not for this survey.
Where is it?
All right. I want to do 2 more things and then we're done for today. So, yeah. Sorry, this has taken a lot longer than I thought it would, but I want to cover this thoroughly with you because you need all this next year. By the way, I think I will make you resit the test for this topic if you don't pass it. Because I don't think I can let you into year 12 if you haven't passed this topic under test conditions.
Or what we just did.
Like the whole chapter.
The statistics one.
Yeah. Like if you're going to do year 12 next year, you have to know this topic. So huh?
Can you discreetly do it?
Absolutely. Discreetly, so that not everyone knows. Of course. I'm not going to write everyone's grade on the board. No. Okay, so guys, listen. Just hang in there. We're nearly done. A lot of the time, I need you to listen because you need this. So a lot of the time, we're not so interested in the counts. I'm just interested in the proportions or percentages. So if I know, for example, that 50% of people chose sumo wrestling because it's so popular, then I would know half the people in the survey chose it. And I don't really need to know how many people took the survey. So we just did it. We just did a unit on percentages. So hopefully you can tell me how you might convert 3 out of 16 to a percentage.
3 over 16 is 500.
Okay. And if you do that, you should get 1875. Just check that for me. Okay? So that's how you would fill in the percentage column. You need to do it for every one. Now, do I need to do the calculation again for netball?
No.
Frequency is the same. So that one's also.
And then it's saying it should all add up to 100%.
Yep. Okay.
Very cool.
All right. So your homework for the 4 weeks on Friday is to do exercise 2A.
Oh, there you go.
Do
what?
Exercise 2A on the work program.
I actually add one extra.
I'm going to.
So if you're away on Friday, you not only need to do 2A, you also need to watch the YouTube video or watch Ed Rollo. You have Ed Rollo access for this subject. Read the notes and do 2B and 2C because we're going to cover both on Friday.
What did you say?
You have Ed Rollo for this subject. Okay? So you need to do 2B and 2C as well. Either by watching my video or Ed Rollo. Okay? Just know that the references might be different.
Let's see if we're not here.
Yeah.
Oh.
Yes. Your assignments. Yes. Yes. Yes.
Have you seen Water Boy Institute?
People at the school been told that I'm leaving.
It's just my sister told me.
So your sister thinks I'm leaving.
She heard something about it.
Yeah, so I haven't said anything about leaving.
Yeah,
So
I haven't gone around being like,
that worries me a little bit because I haven't made any decision about leaving. Okay? It's just a thing. I've never said anything about leaving. So